Okay, so as you look at the chalkboard, we have a lot in 7-4. There's a A, a B, and a C. So don't let that scare you. We're just brand new. We're going to start super easy today, 2 equations, 2 variables. We're going to work our way up to larger systems of equations. Thursday, we're doing 7.5. If you ask me, that's the easiest section of all the matrix topics. So notice, too, on this short 4-day week, there are no quizzes, tests, anything like that. We're just going to cruise along through our matrices. So, of course, first up, vocabulary. Okay, what is a matrix? You got to fill in the blanks here. A rectangular array of numbers and or variables. So you're going to see some brackets around them. Majority of them just have numbers in them, but you could have a variable in there too, which you will see when we get to some equations coming up in a bit. Now, the next two, the blue and the red, are very important that you don't get those confused. Rows go horizontally, columns vertically. Because you're going to hear me reference, I'm on row 2, column 1. You're going to hear me reference that, and you need to know what value you're taking a look at. So rows always go across, columns up and down. And that is important for when we give the dimensions or the size of a matrix. When you give the dimensions or size, same thing, you always give the rows first, horizontal, and then the columns. Especially, not so much today, but when we start using our graphing calculator for some of this stuff, you have to put in the size of the matrix. So you have to first tell it the rows, then the columns. Otherwise, it will set up your matrix incorrectly. So easy stuff, just keep it straight, rows first, columns second. So we're going to show you today how to first give the size, we're going to practice that, super easy, and how to use these to solve a system of equations. Now, first matrix, this is pathetic, this is so easy. It's only one value. So you have one row, one column. So we call this a 1-by-1 matrix. All right, B. Going across, there's only one row. There are 1, 2, 3, 4 columns. So that's how you would give the size. Let me scroll it down. I need a bigger screen. Okay, how many rows for this guy? 3. 3 rows across. How many columns? 2. So if I asked you, what value is in row 3, column 2? What's in row 3, column 2? So third row, second column. So you have to be able to, working our way up to it, identify where these values are. If I ask you on this one, what is in row 2, column 1? 2. Second row, first column. All right, D, what do you got for, this is easy, what's the size of D? 2 by 2, 2 rows, 2 columns. This is what we call the zero matrix. Because everything's got 0. I know, it's very exciting stuff. Now, what, again, working our way up, baby steps. Next thing I'm going to show you is how you can take a system of equations and write it as a matrix. Because we're going to use matrices to solve some systems today. And I like it. Once you get good at it, because I'm quick at multiplying and adding, you don't have to use all of the variables. So that's what's nice, or what I like about it. So 2 equations, so I'm kind of setting up my matrix in my mind. I'm thinking 2 rows, so kind of set that up. We have enough room for 2 rows. Now, how do you write out your matrix? The first column are the coefficients on x. So you have a 1x and a negative 1x. So that's your first column. Second column, the coefficients on y. So 3 and negative 5. Now, for the equal sign, I like to put it in. I'm not going to get upset if you don't or mark off. But for the equal sign, we use a little dash line to represent that. Again, if you don't put it in, I'm not going to freak out about it. And then, of course, our values on the very right here is our last column, what you equal. So first, just practicing writing a system into a matrix form. Now, if you're ahead of me, be careful on B. If you're missing any variables, you need a 0 to hold the place. So you've got 3 equations, so I'm thinking 3 rows. I'm going to first column my coefficients on x. I have 1, I don't have any, and I have 1. So anytime you're missing a term, you need 0 to hold the place. Okay, y's, I've got 3, negative 1, and a goose egg. Okay, z's, I don't have any in the top one. I've got 4, -5. I'm going to put the dash line for the equal just because I like it. Again, I'm not going to freak out if you don't. And then, of course, the right-hand side is our column. What we need. So again, just be conscientious as we write these. If you're missing any terms, 0 holds the place. Keep everything lined up. So any questions about that? All right, so here's what we're going to be doing today. We're going to be using what's called elementary row operations. Now, this is all on your notes. There's nothing for you to fill in, but let's talk about it. Because this screen is what I'm going to be using the next several days, my friends. So here are the only operations you are allowed to use today. You can interchange 2 rows. I can move the bottom to the top, top to the bottom. Because does it really matter what order I stack the equations? No, I can randomly stack them however I want. Now, you can multiply a row by a non-zero constant. So I could multiply everything by 5. It's not going to change the value of your equation, just the looks of it, like 2/4, 1/2, it's all the same thing. Notice it says you can't multiply by 0, because that would make the whole thing 0. So you can multiply by anything. Now, this is kind of tongue-in-cheek. What's the opposite of multiply? So if I said you can multiply by 2, you could also, of course, multiply by 1/2. You could divide by 2. Those are the same thing. So if you hate fractions, if I say I'm going to multiply this row by 1/2, well, it's the same as dividing by 2. Okay? So just be aware of that. Now, the bottom one, we're going to use this today also. Add a multiple of a row to another. So I'm going to maybe multiply a row by 5, and I'm going to add it into another row. So what you really have to kind of think in your mind, you can only multiply and add today. That's your operation. If you want to interchange the equations, we can do it. That's as far as we're going to go. So let's just practice some easy stuff here. I need you to interchange the first and second rows. That's all you have to do. So you have to know what's moving where. It's easy.
Wait.
So we're going to interchange the first 2 rows, first and second row. So it doesn't say anything about the bottom row. Row 3 is staying where it's at. All right, what's your top row? And then our middle row. That is how you interchange 2 rows. I know, it's very exciting stuff here. Yeah, working our way up in baby steps. Now you'll see too, you know I like to get dramatic on the answer keys and stuff and show the work and whatnot. You might see too, and I'm famous for this through this whole stuff, I like to kind of write my row operations on the side, what I'm doing, so you know. So you might see something like this. Row 1 interchange with row 2. Do I care if you write the fancy notes? No, but I just like to put them on there so you know exactly what I'm doing. So the arrow on both sides just means I swapped them, I interchanged them. Do you have to write that? No, but I like to put it. All right, multiply the first row by 1/2. You can do that. I think you can multiply by 1/2, right? I hope. I have faith in you. If you don't like multiplying by 1/2, it's the same as dividing by 2. You want to think about that one? All right, you should have it done already. So top row by 1/2. So you're going to have what? 1, 3. Now, the bottom 2 rows, it didn't say to do anything. I'm just filling them in. Yeah. Any questions? Too easy, too easy. Okay, so to solve these systems of equations, we are going to put them in this very specific form called reduced row echelon form. Or, that is a mouthful, RREF. Okay, this is very specific. Now, to do your matrix in reduced row echelon form, this is what we're going to make ours look like today. So, you're going to start with 1. You got to start with what? Your next number underneath it, 0. Your next column, underneath it. Of course, you're going to have your equal sign. I don't care if you put the dash line in or not. And then your last column over here, I don't care what numbers these are. They can be whatever. I'm just going to put the number symbol. Now, the reason why we want it in this form, if I said rewrite this top row equation style, I'd have 1x, I'm just going to put x, 0y, I'm not going to write that, equals whatever this number is. If I said to rewrite the bottom row equation style, 0x, I'm not writing that, 1y equals whatever the number is. So if you get it in reduced row echelon form, the last columns are your answers. And of course we're going to add, tomorrow we're going to do 3 equations, 3 variables. We're going to keep doing bigger systems with that. Now, to also help your cause, let me give you an order to work in. I always start, I kind of work in like a U. I start in the top left. So this is your first step. Is you want to make sure you have a 1. Now, if you don't have a 1, depends on the problem. Maybe there's a 1 underneath. I could just interchange them. If I don't have a 1, I could divide, if that's 8, I could divide everything by 8, okay? I'm going to do whatever I have to do to get a 1. My next step is I'm going to change this into a 0. So I'm going to put step 2. So specific order we're going to work in. Then I'm going to work on this blue one. So that's my third step. And obviously my last number I'm going to change is that green 0. Now, I'm going to be perfectly honest with you. Would I ever, you can see those systems on your paper here. Would I ever solve those systems with this if I just had a choice? No, I sure wouldn't, okay? I definitely would not. But we're going to start easy with small systems because we are going to work our way up to larger ones. So we're starting with 2 equations, 2 variables. I would never do all of this work for just these easy systems. Working our way up. Ethan, did you have a question for me?
I retract my question.
Okay, all right. I just wanted to make sure I didn't ignore you. All right, here we go. So first, write that into a matrix style. Maybe do something smart on the bottom equation. So the top one I'm just going to fill in. I've got 1x. Let's use green. 1x, negative 6y. I'm going to put the dashed. Now, I said maybe do something smart on the bottom one. What am I hinting at? I'd probably divide it by 3. Remember, just like last chapter, always easier, less opportunity for mistakes if you work on smaller numbers. I don't care if you divide by 3 or negative 3, whatever. I'm going to divide by 3. Now, you know I like to put my fancy row operations. I don't care if you do. I'm going to write here that I did this row divided by 3. Or you multiply by 1/3 if you want to think fraction style. Okay, let's work on it. Here we go. Now, first, order counts. We're starting in the top left corner. I was super nice to you. You already have a 1 there. We don't have to do anything. That is a win. So I'm going to go ahead and just recopy in this first row. Because we wanted this 1 in the corner. Now, I'm going to be honest, probably like 90% of the time you have a 1 up there to start with, so it's not that big of a deal. Now, next number I'm working on is this. I need that to be 0. Now, super easy. How can you turn that into 0?
Add 1.
I just add them, right? If I add these together, is that 0? 1 plus negative 1 is not 0? It is. Mental math. So here's what I'm going to do. I'm going to add row 1 and row 2 together. John.
How's that 3? Yeah.
Oh, sorry, 1. Sorry. I was writing and talking. Good catch, John, before we got too carried away here. Good catch before I got carried away. All right, add them up. So I'm going to have 0. What's negative 6 plus 1? Negative 5. And what's 6 plus 4? Now, I can tell you right now what y is. Get ready. Get ready. Now, remember your order. I'm going to click it back a slide. This is what I'm at now. I need that to be a 1. I'm looking at the bottom row. I can make that negative 5 a 1 piece of cake. I'm just going to divide this by what? Negative 5. Now, here's another pro tip. I got to be honest. I don't want to rewrite this whole darn matrix to divide these by negative 5. I'm just going to write over them. Because if you divide this by negative 5, is it still 0? Yeah, right? Okay. Divide by negative 5. Divide by negative 5. What is this? I now know what y is. Because if I said write this equation style, 0x, 1y equals negative 2. I'm just going to jot it on the side here so I don't lose it. Now, last and final number we have to change. What is it? -6. And here's kind of how I think of it. To make sure I'm in reduced row echelon form, you have this like diagonal ones, and then the other two values are 0. Okay? So we like our bottom row. We're going to keep our bottom row. But I'm going to write it in with my 0, 1, -2. Okay, here's where it's going to get fun. Ready? Answer this easy question for me first. Easy question. What eliminates a -6? So I'm going to do, because you know I like to write my fancy row operation, I'm going to do 6 times the bottom row. So I'm going to multiply all of these by 6. So think about 6 times 0, 6 times 1, 6 times that. I'm going to add it to the top. Now again, I don't care if you write the fancy row operations, I like them so you know what I mean. So here we go, mental math. 6 times 0 plus 1. I need longer arms. 6 times 1 plus -6, which is what I was after. 6 times -2, -12 plus 6. X is so, like I said, I would never ever do all of this work to solve that simple system if I had a choice. But we're working our way up to 3 equations, 3 variables, 4 equations, 4 variables, which it is a lot faster than having to write all the numbers and do all the elimination. Baby steps, baby steps. Let's do a couple more. Okay. Oh, this is a good one. I like this one. All right, write it as a matrix. Start with the easy steps. Okay, look at your bottom equation. We probably should what? Yeah, I'd reduce it. I always reduce just it always I think it makes it a little easier. I'm going to divide by 3. You can. You can. So first just set it up. That's nice and easy. Now think about what order you're supposed to work in. We're supposed to start in the top left corner. I need that to be a 1. So we got a couple of problems here. It's clearly not a 1. If this was underneath a 1, I would just flip-flop the rows. That's no big deal. Unfortunately, I don't have that. So we might have to deal with a fraction here for a minute, because if I were to make this a 1, I'd have to divide it by what? 3, which is going to make a fraction and a fraction. Not the world's worst fractions, but we're going to have to deal with a fraction here. So I'm going to do this top row divided by 3. So 3 divided by 3. -1 divided by 3. We should be able to handle a third in here. And 1 divided by 3. I didn't do anything on the bottom row. I'm just going to recover it or fill it back in here. Okay. So you might, not a lot, because there are fractions in the problems. You know, it's pretty nice to start it off, but you might have to deal with something like a third or a half or something small. All right, next number. What's our next number we're working on? Okay, so I'm going to fill in the top row. I'm going to keep all that crazy fraction action. And we'll work on this bottom row because we need that -3 to be a 0. So here we go. So first, easy question. What eliminates -3? 3. So we're going to multiply the bottom. We're going to do the top row by 3. And I'm going to add it to the bottom. So I'm going to do all these top red numbers times 3, add them to the bottom. So here we go. Be careful on the fractions. What's 3 times 1? 3 plus that, which is what we were after. Okay, this is nice. What's 3 times -1/3? -1 plus -1. -2. That's nice. That's nice. I like it. What's 3 times 1/3? Plus -5. I can tell you why. Why is? Because can I divide these by -2? Which I'm not going to rewrite it. That's a pain, right? We're just going to write over it. If I divide by -2, still 0. That would be 1. Got it. Okay, we have one final, and I'm going to scroll this up just a little bit so I'm not so much at the bottom here. one final gross number to change. What is it? Okay, so this guy. So my bottom row is perfect. I'm going to go ahead and fill that in. I'm going to try to keep it on here. So my 0, 1, 2 I'm going to keep because our y is kind of sneaking it on the side there. All right, we got to get rid of that negative a third. Now, easy question, easy question. What eliminates a negative 1/3?
1/3.
1/3. So I'm going to do 1/3 times this bottom blue row, and I'm adding it to the top. So I'm going to do a third times these blue numbers, I'm adding them to the top. Back here they're purple, well, purple and blue, I guess. What's a third times 0? Plus 1. Okay, a third times 1, a third plus negative a third, which is what we were after. Now this is going to be nice. What's a third times 2? 2/3. What's 2/3 plus 1/3? 1, 3/3. X is 1. Got it. Even.
Okay, so you're multiplying by the bottom and
Yep.
then adding it to the top?
Yep, you can multiply a row by a value and add it into another row. That's one of your 3 elementary row operations you could use. Let's do another. Okay, and there is, like I have a typo on your notes, but I have it right up here. I think there's like a 2 in there, like take that out.
Oh.
Like they have a typo on yours, right? Because isn't it 2y on the top, is it right? Yeah, so cross that off, cross it off, I have a typo on yours. All right, and I was kind of nice to you on the start here. Now, I said I was kind of nice to you here because what is your first value already? So we're good, okay. So what is your next number you're working on? 2. So I'm going to rewrite in the green row. I'm not going to change it for right now because I like that 1.
Our equations are different.
I know.
We were just
Dude.
I'm still getting confused.
Good listening skills, good listening skills. Okay, easy question. Here we go. What cancels out 2? -2. So we are going to multiply the top row by -2, and you're adding it to this bottom row. So all top numbers times -2. I'm going to do the first one. You're going to do the next ones. 1 times -2 plus 2. You take a few seconds and figure out the next 2 numbers. You gotta be good at mental math here.
I'm locked.
Okay, so what do you get for the next number?
-1.
-1, perfect. Because -2 times 1 is -2 plus 1. And I heard some of you saying this at 1 too. -2 times 7, think about what that is, and add 8 to it. What's your corner number?
-6.
So I can tell you right now y is 6 because we're going to switch the signs. Now I'm not going to rewrite that whole stupid row just to switch some signs. Okay, I think we can do this in just one last round of matrix here because there's only one last number to change. So last number to change, I would ask you what number it is, but there's like 3 of them up here. This one here is the one we got to change into a 0. So our bottom, well mine are red, our bottom red numbers are perfect. We have y is 6. I'm just going to fill in again those bottom red numbers. Got it. Okay. So many 1s up here. I'm working on this with the purple arrow. This one, easy question. What cancels out a 1? So we're going to do -1. I don't care if you have the 1 there or not, you know, negative, times my red numbers, we're adding it to the top. So you're going to do -1 times my red numbers, add them to the green, take a few seconds, see if you get X. right, you should have it by now. Here we go. Negative 1 times 0, 0, plus 1. Negative 1 times 1, negative 1, plus 1, which is what we were after, obviously. What's negative 1 times 6? Negative 6 plus 7. X is? Got it. Okay. So like I said, I would never solve these little systems with this convoluted work, okay? But we're working our way up to bigger systems. We thought we would start small. Now, on your homework today, that's a front and a back. There are 10 problems, 10. I tried to space it out. I write small. If at any time you need to use like loose leaf paper, if you don't have enough room, you're always welcome to do that. I will also tell you this, on your worksheet, I did not need a fraction anywhere. Nowhere. No fractions needed. All answers are whole numbers. There is nothing over a 7 for an answer. Or a negative 7, plus, minus, whatever. But there's no number larger than a 7. So I made it pretty nice.